So sometimes when you graph a system, you get what we call a special case. So say we've got two lines on a grid. So here's my y and x axis here. If I've got two lines with the same slope and different y-intercepts, these lines we call parallel. So if we were to figure out their solutions here, well, they actually wouldn't have any solutions because parallel lines never cross each other, and the solution is where they cross. So if there's parallel lines, that would be no solution. So we might run into that with this special cases here. And what that looks like is some impossible thing. Say, for example, we've got like y equals 2x plus 5 and y equals 2x minus 3. These two things can never be equal because if you were to use substitution, 2x plus 5 cannot equal 2x minus 3 because if you take away those two x's, 5 cannot equal negative 3. So that would be an impossible situation here where the same slope of two different y-intercepts produces an impossibility, so therefore no solutions. There's no place where these lines are going to cross. So if that happens, we just say the lines are parallel and there are no solutions to a system. It's definitely possible. Another special case is if we actually go to graph two lines and they end up being the same line. So what happens is they're actually on top of each other. We call this infinite solutions typically because they're equivalent lines. So the two lines are actually one line. So say, for example, we say y equals 1/2 x plus 7, and then 2y equals 1x plus 14. These two things are the exact same thing because if you just divide everything by 2, you get back to this one. So they may look a little different, but actually end up being equivalent. And if that happens, again, we just call that infinite solutions because they're always equal. They're always going to intersect. They're always the same exact thing. So they're equivalent lines. Those are our two special cases. If you're solving and you get to a situation, what would that look like? Well, what happens is it basically looks like an obvious statement. So say we have y equals 1/2 x plus 7 and then 2y equals x plus 14. So if I were to take this and plug it in for y, I would get 2 times 1/2 x plus 7 equals x plus 14. So multiplying this in gives you x plus 14 equaling x plus 14. This is what I call an obvious statement because it equals itself. So if you get rid of the x's, it would just be 14 equals 14, which again would be infinite solutions because that's always true. It's equivalent. They're always equivalent, no matter what x is, which means that every coordinate will be the same. So those are our two cases here. So let's see for this one, which is which. So the first one I'm going to do here, so 2x equals negative 2 minus 1y. So I'm going to do, I think, elimination for this. I'm going to move the y's over to the other side. So I do that by doing adding. So 2x equals negative 2 minus 1y, so plus 1y to both sides gives us 2x plus 1y minus, or equals negative 2. The bottom one is 4x minus 2y equals 4. So if I try and do opposites here, I'm going to do times 2 to the top. That would be 4x, and bring it down here, plus 2y equaling negative 4. And then from there, so that's a negative 4 there. I didn't carry that negative down. There it is. Knew I missed something there. Okay, so now if I add these two equations, let's see what happens. The x's make 0, the y's make 0, the right side makes 0. 0 equals 0. So what that means is these two lines are actually equivalent. So infinite solutions, these are equivalent lines. They're the exact same line. For the next one here, let's give this a shot. So they're already lined up pretty well for elimination. I'm just going to do times 5 actually to the top one in order to make some opposites here. So I'm going to do times 5 and write it down here. So 25x plus 15y equals 5. And then negative 25x minus 15y equals negative 11. So if I add these, the x's will drop, the y's will drop. We have nothing left on this side, equaling -6. Does 0 equal -6? No, no solutions here. This is impossible. This would be parallel lines. So we've got both special cases there. First one was equivalent. Second one is parallel lines, no solutions.